Hey guys, welcome back to Rocket Gyan, my fellow space tubers. And whoa, after so long, we are back again at doing our favorite business. And yes, today is a special day because many of my subscriber and even you can say the first of my subscriber, Louis Smith, your country, UK, is gonna host a launch today. And finally, after so long, UK is gonna have some launch services of their own, and they don't need to ship uh, the payloads. The startups don't need to ship their CubeSats to the abroad for the launch services, right? Which is great itself. So, welcome to the stream, guys. Welcome back. Hi, Wildflower. How are you? Happy New Year to all of you. Hi, Chris. Hi, Andy, and hi, Eric Benjamin Monteiro. Hi, hi, everyone. Hi, Alex. So, we need to see what is new with this launch, and I'm really excited because this thing is gonna kind of help the UK's small startup industry, because obviously the startups which are coming today, they manufacture CubeSats, right? And they are not so much heavy and all those things. So this thing can actually launch a good amount of weight to synchronous orbit or anything. And the best part of this is it kind of gets help with the kind of gets help from the plane itself to negate the effects of the um, earth when going to a polar orbit. So we'll discuss all about that, but today we gonna see what this company is all about. We all know Virgin. We know Virgin company, right? So that's not a new thing. It's a is a brand, and we know many services from it. But today they are launching this rocket from this cosmic girl. So the first of all, the rocket name is the LauncherOne, and we have okay, a second, yeah. So the launcher name, the rocket name is LauncherOne, and we have the the plane as the cosmic girl. So this is that thing, and we'll talk about the orbital performance also, and all those things. So these are the quick stats that we need to look at. So 300 to 500 kilograms is the actual payload capacity of this launcher. So it can actually launch a small satellite also. It's not like Astra or even Electron, for the matter, that it has a much higher capacity than Electron. Also, Electron, I guess, maxes out at 200 kilograms after this 200 to 300 kilograms after this reusability was introduced. So this yeah it can host a small satellite, and we have inclination. Obviously it does not care about the inclination. You can actually launch to any inclination. 0 to 120 degrees they have actually if this is the most of the time this is the requirement. But theoretically you can actually launch from to any inclination, because you have a plane. You don't need a launch site. You don't have any restriction, right? So that is the reason why you can just launch your plane from any airport in the world which support the facilities which the LauncherOne and the Cosmic Girl needs. So the inclination problem is absolutely solved with this one. Obviously system made in US, and total thrust of the rocket is 80,000 pounds. So let's have a look at the rocket itself now. All right. Let me just have a before looking at the rocket, let's understand how they launch their rockets and with the help of a plane. So first of all, as I said, because they are very flexible with their rocket, because it actually launches from a plane. The launch site itself is a plane. It does not have a constraint of the inclination. You can go to any inclination: low, medium. You can see in the animation too what is medium, what is low, and then high. High inclination means the polar orbit, which it is going today. and low and medium we all know about what we want, but most of the time it's the high orbit inclination which the CubeSats prefer, because it's a polar orbit, it's a sun synchronous orbit. It has two advantages, which means first of all you get proper sunlight all the time at this orbit, and then we have this the since it's a polar orbit, the satellites actually can cover the whole Earth um, with this orbit. And then let's have a look at how the things happen. So this is not a small rocket at all. You can see the size of it. If I'll just yeah, you can see the size of it. This is just the fairing, and it can house a proper, you know, a small satellite, a proper small satellite which does not have much weight to it in it. So yeah, it can actually do most of the things with that, but it does not have a Curie engine, Curie, not a Curie engine, the kick stage which we have in Electron has a kick stage which has a Curie engine, so it's known as Curie kick stage. So with the help of that, if even if they are launching, let's say 100 kilograms to the orbit, they can optimize the orbit capacity, the altitude, and much more refine their target. And that is the reason why Electron is capable of launching something to the moon and even something to the Venus. So that is going to happen with the Electron, but yeah, that is the case here. Then we have the launch site. It's not California today, it's Cornwall, UK, and it's gonna launch from the UK for the first time. So let's have a look at the launch process. So first of all, this is the Cosmic Girl. It's a special plane which is actually this plane itself was selected because if you can see, it has this rocket which is mounted on the wing of this plane, and this plane had this advantage because this plane was designed in such a way that it can carry an extra engine in case of if you need to transport an extra jet engine, airplane engine, then you can just attach that engine in on that wing. So this plane was actually made in such a way so that it can support some extra weight in one side of the wing, and that is the reason why this is selected, and it has been modified and optimized to so that they can mount the LauncherOne rocket. But yes, the Cosmic Girl is there, which you can see. Then the takeoff happens, and after that it goes to the proper launch site where the rocket gets deployed. So the Cosmic Girl can take around 30 minutes or 4 hours before reaching the deployment zone, and it at a cruising altitude of 35,000 feet and a 45 degrees steep angle, the pilot hits the big red button, and he says release, 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 and then smash that big red button. The rocket gets detached. Then after that, the rocket has a free fall for 4 seconds or so, and it is angled at 27 degree, not 45 degree. So it is angled at 27 degree. After a 4-second free fall, the first stage engine, the Newton 3, comes into action. And this we'll talk about the rocket also, what are the specifics about this rocket. But yeah, the first stage comes into action, and then it reaches the orbit after that. And then the second stage, we also have a second stage on it, which the Newton 4 engine, that is what supports the second stage. It comes in and delivers the payload. That's a vacuum optimized engine, delivers the payload to the intended orbit. So yeah, that is how it is. So this is the launch process. Let's have a look at the rocket itself. So we have this rocket. Where is it? Yeah. So let's have a look at the rocket 3D view. So this is a LauncherOne rocket. Let's just explore it a little further. So this is a 2-stage rocket. The first stage, if you can see here, it's a very good design, and yeah, I'm happy with it. So let's have a look at it. So the first stage has these fins, which are actually needed because it will be launched at some speed, right? So at some speed and in thick atmosphere, the stability will be a big issue, and that is the reason why, by just having this fins, even though the engine itself can gimbal, but the having this fins ensures that the rocket remains stable even at high speeds when it is released. Okay. And one more thing which, if you notice, very what should I say, sharply, you can see here we have something. Here we have some sort of thrusters. So these are thrusters which are actually these four thrusters are, what should I say, I can't recall the name at the moment, but their main purpose of these thrusters is to provide an extra, that ullage kind of an effect, which means when the rocket engine is not started during the free fall, first of all these thrusters are ignited so that all that fuel which is just wobbling all around can come to the bottom, and then the engine is ignited. So this Newton 3 engine runs on RP1 and LOX as its fuel. We are not so sure about its cycle, because they are very secretive about this, their engine capability. So we don't know about the cycle, but we do know they run on RP1 and LOX as its engine. And also we have this special thruster which you can see. This I don't these two thrusters are actually intended so that it provides a, what should I say, a proper thrust in this direction, making sure it has a proper angle of attack every time it is going to space. So that is the case here. So if you can look at it, it does not have a thruster here, because it is and you can see it is inclined at an angle also. The main purpose of these thrusters is to make sure that the angle of attack is maintained during the flight. So yeah, there is that. And then comes to the second stage, which is the Newton 4 engine. This is a vacuum optimized engine, again runs on RP1 and LOX as its fuel. They say it as a Newton 4, but I guess this is just a vacuum optimized version of the first stage. Not so sure about it, again, because they are kind of secretive about how it is. So yeah, so this is all about the rocket. We can also have a look at the exploded view, which actually has a proper, oops, second. So here you can see this infographic actually explains it all along. So 71.8 meter outer diameter composite structure, obviously it needs that. It does not it can't support its weight on if it is made on stainless steel, as in Starship does not have proper engines in there, right? So we have this we have this Newton 3 engine, 3-minute runtime, RP1 and LOX as its fuel. You can see that the interstate separator here. Then we have the Newton 4, which has 6 minutes of runtime, and it can allow 2 burns for the circularization if needed. So kind of what should I say, restartable. And then we have the payload, maximum payload capacity of 500 kilograms, typical altitude of 500 to 1000 kilograms. So one more thing which I needed to add is the gimbal capability of Newton 3. Since we are secretive, they are secretive about the engine technology. Again, I'm not so sure about the gimbal capability, but since they have a proper thruster which is attached to maintain the angle of attack, I kind of think it does not have a gimbal capability. So yeah, that is the case here. Makes it even much more simpler to make and assemble. So yeah, there's that. Okay, now let's have a look at how the rocket or the Cosmic Girl will go to space and liftoff will happen. So here we have the Cornwall airport here. So the mission, the flight path is gonna happen like this. So the Cosmic Girl will take off from here. It will go at this point near this. I am not so sure about what do we call what is the region here, but the local people of UK must be knowing that. But yeah, so the flight path is very simple. it will go to this area, then this area, in this area it will what will happen is it will take a one round circle here and then come back here again and then drop. This is the LauncherOne drop point, which means at this point the LauncherOne will be detached from the Cosmic Girl. The launcher will one obviously will just move on to its destination, which is the space. The Cosmic Girl will again take this U-turn, come here and then follow this flight path to make sure it lands again on the Cornwall airport. So the first stage is the Cosmic Girl itself, and this is how the flight path of the Cosmic Girl would look like. Okay, so now let's have a look at the payloads and everything which are going to the space today. So if we just look at that, yeah, so we have this payload which is it is named as IOD-3 Amber. Amber is the partnership between the UK Satellite Application Catapult Agency and Horizon Technology. So it is expected to be the first of 24 satellites that will provide maritime domain awareness to the users. So it will actually basically monitor the radio signals, and the IOD is in orbit demonstration of the tracking of the vessels and all those things. So you can see it has the radio frequency emissions. The vessels in the oceans have a certain radio frequency. This satellite is used to monitor that. So first satellite is that. The second satellite is the kind of the main customer, which is the Prometheus 2. So this mission consists of two 6U CubeSats, Prometheus 2A and 2B, and they have been manufactured by In-Space Mission. The satellite will be owned by the UK's Defence Science and Technology Laboratory on behalf of UK's Ministry of Defence. They were designed jointly by In-Space Mission and Airbus Defence and Space. So yeah, there's that. But what they do is they provide a test platform for MOD science and technology activities both in space and on land. That will happen. They basically they will be used for monitoring radio signals, including GPS. So they will be using what we called as software defined radio technology, which will be used for research purposes as opposed to the defense intelligence. So this satellite is mostly for research purposes, basically to make sure they have a proper knowledge of how the things work in the radio signals department, including GPS also. So once they master that, then they will be able to make sure they have that big satellites which will be stationed in the geostationary orbit, most probably. So yeah, after that we have this how do I pronounce that? CIRCE. CIRCE, or I don't know, but it's a miniaturized space weather platform hosting 3 payloads. The CIRCE stands for Coordinated Ionospheric Reconstruction CubeSat Experiment, and it will be basically the work of these satellites is to make sure they monitor the space weather with the help of it. So yeah, this is that. The next satellite is the Dover. This is the Dover, which is the payload named after the Dover Strait or Dover Strait, whatever you want to say, the narrowest part of the English Channel, right? So it is again designed by space company Open Cosmos, which is a UK startup, and built by the RIA group from the Belgium. So this will transmit signals designed for use in positioning, navigation, and timing. This is a term that is used in GPS. So kind of you can say that it will transmit the GPS signals. So UK government is trying to have its own this GPS PNT capability, positioning, navigation, and timing system. So this will help in that. So this is this Dover satellite. So next one is kind of my favorite one. This is a Forge Star Zero, and they are a very unique startup. This company the 4-star 0 is going to launch today. This is the render for the 4-star one, but this company named as Space Forge itself, the name itself suggests what is actually going to happen. So they are literally going, this is a startup which is going for manufacturing in space. Not only manufacturing, but also delivering your payloads to space, as well as then returning it back to the earth. So this is a very interesting startup which has come into place. So Forge Start 0 is going to test the re-entry capability. So let me just show you the websites for it. So this is the website. You can see the next industry revolution isn't on earth, obviously. Right now it's industry 4.0, which is data. After that maybe in space, but right now, yeah, that is the case here. So the Space Force is transforming return from space to enable revolutionary products for the benefit of humanity, manufacture new materials for a new earth age, electronics, pharma, alloys, which is not possible on earth. So the manufacturing, the challenges on earth which is there, you can see the gravity causes buoyancy, which prevents perfect alloying in metals, and also the gravity causes there is one thing I was watching Discovery once, and there was one space startup from US which was supposed to manufacture some crystals which will help in optical fiber communication. Right now the impurities in the optical fiber communication line is so much that the actual speed of light is not established in that. So with the help of space manufacturing, those impurities are removed, because those impurities happen because of the gravity. The crystallization can't happen because of the gravity, but in space that is not the case. So they can make it very pure and hence improve the speed of your internet basically, and even improve the speed of your internet. So gravity is a case here which we don't consider, but yeah, that is the case. Then the atmosphere is also there on earth, which contaminates even the cleanest of the processes. So yeah, that is a problem. Then obviously a temperature, we don't have a cooling furnace, cold storage. We need to make some cold storage to make sure and things happen, right? From freezers to furnaces, temperature extremes are difficult to create and maintain, obviously. Now the benefits of space: vacuum is there, so lower ambient pressure removes any contamination issues, and yeah, obviously that is the case. And then the weightlessness, there is no gravity, so proper manufacturing of alloys and all those things, perfect crystal formation, basically that is the main thing which happens without gravity. And then we have near zero temperature in space, so radiators facing cold space can freely produce temperature near absolute zero for ultra fast curing without the need for cryogenic. So yeah, there's that. So this is the thing. So they also have this microgravity, not only the manufacturing part, they also have this thing called microgravity as a service. You must have heard of SaaS, which is software as a service, or stream video as a service, all those things. Microgravity as a service. So the launch will happen, the deployment will happen, operation of the manufacturing, everything which you want to manufacture, that happens, and then this thing returns back to the earth, land on the earth, and then they refurbish it, this thing back for new operation. So for today's, the 4-star 0 will actually test this thing, the re-entry capability, and make sure the satellite survives the re-entry and all those things. So yeah, this is how it would look like. It's a very interesting startup, and I wanted to talk about this. So that was one thing. No, they are not Starlink, Henry. This is a very different one. This is like manufacturing in space. Not only manufacturing in space, but also make sure you launch it in space on their platform, manufacture in space on their platform, and then you can also make sure that your payload or anything which you have made is returned back on the earth to use it. Obviously something you manufacture in space, it needs to get back to the earth, right? So it makes sense to have something like this. So yeah, that is the case here. Now we'll have a look at this one. So we have another satellite which is known as Aman, uh, which is from the Oman. So this is the Oman's first satellite. It has been built by the Polish company SatRev, and the purpose of the satellite is to demonstrate Earth observation technologies. And yeah, so we on in this era of space faring world, there are still certain nations which does not even have a satellite in space. So Oman is one of them, and today they are going to have a satellite in space, which is amazing to see that the every not only developed nations but uh, developing as well as underdeveloped nations are getting some support so that they also can utilize the benefits of space. Okay, the next one which we have is the Stork 6. This is our 3U CubeSat built by Sat Rev of Poland, and it joins a constellation of 14 when fully populated. This is nothing but a Vision 300 imager which provides a ground resolution of 5 meter. This takes up to yeah, the ground resolution of 5 meter. That is one thing. SatRev has previously launched Stock 3 and SteamSat 2. Stock 1 and 2 have been launched already. Stock 4 and 5 also launched on the tubular bells for the from the Virgin orbit only, and then now it's Stock 6 will be launching. So yeah, this is how it is. So these are all the payloads which are going to space today, and the combined mass of all the payloads is around 100 kilograms. So there is that. Now let's have a look at the mission profile. So the typical mission profile for the Virgin orbit looks like this. So this is the LauncherOne mission profile. We already talked about the Cosmic Girl mission profile, the flight profile. Let's talk about the LauncherOne flight profile. So the rocket engine happens, the main engine start happens after this certain time, you know, just seconds. So let's look into that. After that, the first stage engine burns, the stage separation happens. After the stage separation, the first of all the main engine cut off happens, then the stage separation happens, the second engine start one happen, and then at this point the fairing separation is also there. So after that, the Seco 1 happens for the first time. Then we have the second engine start 2. This start 2 is basically to make sure there is a proper circularization of the orbit which is there. And after that, as SES2, we have a very little burn time to make sure that is fully circularized. Then we have a Seco 2, and then finally the payload separation. So yeah, this is how it looks like. So we have already concluded, make sure everything we know about this mission, and this is just a recap, and this is how actually it looks like, you know. This is the Cosmic Girl, this is the LauncherOne. This is how it looks like in the from the fairing. Obviously above the clouds the Mach effects come into place, and yeah, first mission from the UK. This is their emblem, the patch, the mission patch for this one, this launch. And we have talked about these thing this. So actually, you know guys, the Virgin is there always dedicating their launches to some sort of songs or something. So the launch name Start Me Up is a tribute to one of the most iconic British rock and roll bands of all time, the Rolling Stones. The hit song debuted on 1981 album. So yes, this stream is gonna have some copyright issues, but that is how it is. The Virgin is kind of into music. Music is what made Virgin so popular and so valuable. So yeah, they should not forget about it. Yeah, but the problem with this launcher is, as all the Virgin products, this is also a costlier one. So the cost per launch for the LauncherOne is around $12 million, which is whoa, too much, because in comparison to the Electron launches at around $7 to $8 million, which itself is not a very great price. So a $12 million launch, launcher is there, so it's a costlier one, but it does provide some cool services. So I guess, yeah, it makes up for that. So let's so we have 1,000 people tuning in. Welcome back, welcome here to this live stream, guys. So if you have any questions, do ask me, and let me see if we have the live stream, and I'll switch over to that. We are still waiting for the live stream to happen. Are they going to have a live stream, or is it scrubbed? Let me just have a look at that. You just enjoy this rocket for a second. Let me just make sure, because they haven't started the launch live stream. We have the live stream. There is an scrub. This. Yep, it's going to happen. We are waiting for the live stream to happen, but it's not scrubbed. So yeah, that is a good thing to hear about. So it's a good time to, guys, answer some questions if you are having, and we'll have a look at it. So just ask me something. And guys, if you are new to this channel, let me just tell you that on this channel we do live stream of almost all the rocket launches that happen on the world, and you just saw what I do in the live stream. I try to explain each and every aspect of the rocket, the mission, and how the things work. So if you are new here, please guys, do subscribe me. You won't regret it for sure, I'm telling you that, if you are into the rockets and everything. And if you are not also, then also just, you know, watch the launches for their beauty, and the just you know, when the rocket launches and the liftoff happens, just stop everything and enjoy the launch. Just, you know, what should we say, just dive down into the beautiful scenery which the rocket creates, and just watch it for that. So yeah, that is the case. So let me just look at, okay, I see bad weather coming in. Don't say that. We are having we are not having a scrub, so that is a good thing. So I don't have a launch viewer map, guys, so we'll have to you know, figure it out. Is the rocket LGBTQ? Nope. The countdown for the takeoff of the nope, it's the firing of the rocket motors, Jay. So yeah, that's a good question. So T-1 hour 51 minutes is the firing of the rocket engines. So the Cosmic Girls kind of lifts off around it actually, you know, changes every launch, it changes. So we are not so sure about when it would launch, but typical launch timing for the Cosmic Girl is around T-45 to 1 hour. So yeah. And Clark says, see, so a plane takes off, flies miles out to the sea where it's safe and launches a rocket. Who would say it? Well, that's a very valid question, and a very valid kind of an argument. So yeah, that is a issue for the viewers. But when the rocket motor ignites, then but actually the thing with this is you can't catch this launch from the ground, because it actually launches above the clouds, you know, and if the clouds are there, then you can't see it at all. If you kind of see any small dot in the sky, a small fire arrow in the sky, you can't see that if it is just you know, having the clouds in there. So yeah, it's an issue, but kind of a unique way And let me just tell you that it's not the first time that the someone is launching some rockets from the plane. There was a thing, and there was a system, and there was a uh, plane, the rocket, actually the rocket name, and the program named as Pegasus. So it was a, it had similar thing. The rocket, the rocket was attached to the plane, and then it was launched, and it was from US, if I'm not wrong. And it was actually made to deliver those defense payloads on demand to the low Earth orbit or anything, all those things. But it was very costly to maintain and very costly to make. So I guess very recently only they had one launch, and after that, I guess they have shut down the operations. Not so sure about it, but yeah, that is the case here. Okay, so all right. So guys, if you want to support me in what I do, please look out for those memberships. It would really help me. And other than that, let's have a talk about what's the weather update. I'm not so sure why they are taking so long. Actually, you know what happens? Sometimes things, technical difficulties happens, and they don't start the live stream because they have some issue at the range. Actually, the range does not matter here. Kind of matter here, but it's the range is actually in the sea, so far in the sea to be precise. But still what it is, they need to see the weather up there. Yes, the kind of the advantage this type of launch also gets, that they, if a weather is not good at a certain place, they can just move on to a newer location to launch the rocket. As simple as that. So it does not, I won't say completely eradicate the weather constraints, but still it has this flexibility to properly maneuver itself from the bad weather conditions to a good weather condition. But obviously all the calculation, the orbital mechanics, all those things which are needed to be fed in computer, that needs to happen, and they need to do all the simulations and everything. But it's not like it's not like it's not theoretically possible. Yes, it is theoretically possible to kind of move away from the bad weather and launch it from somewhere else, but companies don't do it because they need to change the, again, all those equations, right? Feed it into the computer, and also the margin of error with this rocket is so low because it is not a very powerful rocket or a very fuel efficient one. Fuel efficient in the sense means it does not have much fuel in it, so the margin of error is very less. So yeah, whatever they decide, they kind of do it from there. But yeah, in future they have this flexibility to improve that. Right? What's the best rocket lab? Well, that's a topic of discussion. That's a talk, not a discussion, but debate actually. Okay. Can the rocket motor launch be delayed by minutes until the pilot is ready and in correct position? Yes, it can happen. Betty. It has happened when the pilot does not feel that the things are all right for the rocket to launch. If there is any technical difficulty or the weather is not supporting or anything else, yes, the pilot can decide to hold it off for a certain second, and that is the reason why let me just pull it again, that graphic. Yeah, this one, this circle maneuver is important. This is the reason why, because if anything happens that the pilot is decides, or the weather is not good, or the pilot decides there is some issue which needs to be worked on, this circle, the pilot can just circle in this kind of a strip, and m- when the team is confident, the pilot is confident enough, they can just launch it afterwards, after circling a few more times. But obviously they will have some cutoff time after a cutoff circles, or whatever you want to say. After that, they would not risk the launch, because then the equations drastically changes. uh, Actually, it does not drastically changes, but still, again, I'm again coming to that point only. The margin of error with this rocket is very less. So they need to be very precise with the launch. So if you are just joining in, guys, this is don't you mean specific impulse? Specific impulse is kind of the mileage. It's not the mileage issue here. Again, it's the proper is the issue with this rocket is the engine power as well as the fuel tank. The mileage issue, I don't think so. It's a mileage issue here. It's just RP1 and LOX liquid fuel engine. So all not the most efficient of all those RP1 and LOX, but still it does its job. So yeah. Then just wait for some time. I'm just trying to trying to have some discussion with you guys, so that you can have a good time when you actually see this launch, because the stream has not started yet. Okay, yes it. So I'll switch over to that. Raj says, why do they have to fly the rocket first into before they launch? Well, that's a good question. It's not a problem. Actually, it all comes down to the range issue, because again, it's a rocket only, right? At the end of the day, it's a rocket, and it has its safety issues. So once the rocket launches, they prefer it over the seas, because the range is proper there. There is no safety concern. If the blast happens, then also it won't, the pieces won't fall over the public. So yeah, that is the case, and that is the reason why that happened. So yeah, the live stream has started. I'll switch over to that. Just give me a second, guys. This going to get me a copyright. Wait a second.
Launch will change the world.
Welcome to Start Me Up. We are live from Spaceport Cornwall here in beautiful Cornwall, UK. My name is Melissa Thorpe, and I am the head of Spaceport Cornwall, where I'm so privileged to lead my incredible team in turning an airport into a spaceport. I'm also so lucky to have in the studio with me Natalie, and across the pond in Long Beach, Chris.
I'm Natalie Burgos, Senior Producer of Live Broadcasts and Events. I work on a team in charge of brand and communications. And back over to you, Chris.
Yeah, hi, I'm Chris Rolfe. I'm the Director of Systems Engineering and Verification here at Virgin Orbit. And my teams include the interdisciplinary engineers that own the high-level definition, design, and verification of our launch program. As Mel said, I'm your North American correspondent for today. I'm here in sunny Long Beach, California, at our payload processing facility, just down the street from the rocket, just down the street from the factory where the rocket you'll see launch today was built. Back to you in the UK.
Well, this is an exciting mission built on a tried and true platform, but not just for Virgin Orbit being our first international launch, but with multiple partners. So.
Yeah, and it's our first ever launch here from the UK, and that's so exciting for us, as well as the first orbital launch from Europe. It's also the first launch for some of our customers, including our friends at Spaceforge from Cardiff, as well as the Sultanate of Oman. It's truly an exciting moment for us here. The crowd outside is really excited. I hope you can feel that energy across the pond in Long Beach, Chris.
Mel, although this isn't our first launch here at Virgin Orbit, every launch is exciting and we're feeling your excitement too. And just before we came online, I saw there was about 25,000 people that were already in the waiting room for the YouTube stream of this. So there's a lot of people that are excited here as well. So today you're going to be hearing over the program the audio from our MCC, or our Mission Control Center. And what that is you'll hear a lot of people on that line, including folks like our launch director, our ground crew, our department consoles, our flight crew, and our launch engineers. And anything that they're talking through today, if there's a little extra information that I can provide, a little extra color, I'll do that. This morning I sat in on the morning briefing. Our aircraft systems, rocket systems, ground systems, and our weather, both ground and, if you can imagine, our space weather, are all nominal, and we are go for launch today.
That's what
Another
we're
thing
hear.
that you're going to see throughout the program today are our graphical user interfaces, or our GUIs. And we're going to bring up our rocket load GUI right now.
Look at that.
As you can see on the screen here, we have our LauncherOne in the top section of the screen. On the left is our stage 1, which does most of the heavy lifting. On the right is our stage 2, and that's the pointy end where all our payloads live. This is live data that you're seeing right now coming from our systems. You can see that both our fuel, which is RP1, and our liquid oxygen, our oxidizer, is at 100% for both of our stages, as well as our helium, both cold and hot helium. Everything else here looks normal right now. Our pressures are good, our battery bus voltages are good, Cosmic Girl is performing normally, including our pallets and pylons. And as I said, we'll be seeing different GUIs through the program depending on the stages of flight that we're in. But for now, we're going to watch a quick video on some information on the UK Space Agency.
It's an immensely exciting period for the UK to be part of the very first launch of satellites into orbit from the UK. More so than that, the very first time that satellites have been launched into orbit from Europe as well. It marks a seminal point in the growth of the space economy for the UK, unlocking jobs regionally and nationally on the back of an £11 million investment in Cornwall with Virgin Orbit. Deeply excited to be involved, but more than that, it demonstrates the UK's position within the sector, launch alongside satellite design, manufacture, satellite operations, and the exploitation of downstream data as well. And more importantly, inspiring the next generation of youngsters to become involved in the space sector, whether from a technical perspective or from a business perspective as well. So for me, it's a moment of personal pride, but it also marks an immense amount of pride from the agency, across government, across our partners with Virgin Orbit and Spaceport Cornwall, and also it's a moment of national pride to be inspired through British technology and British leadership.
Well, there you go.
So why are we here today? One word: satellites. Satellites underpin so much of our daily lives, and we're so lucky to have several of them flying with us today.
Spaceman exact.
First up is Prometheus 2 from the National Reconnaissance Office. And Prometheus 2 is 2 CubeSats, and it's a great example of joint UK-US partnership. Let's hear a little bit more about this amazing technology.
Henry, actually I like that touch, you know. This a guy translating the sign language, basically doing something for all the deaf people out there. So really like that touch. But yeah, we have already talked about all those satellites. The Prometheus is actually the main customer flying today, and we are going to. So right now you can see all those things. The expected takeoff time is around 10:01 p.m. So that's the takeoff time. So there is a plane which is involved in this launch. So the takeoff will happen at 10:01. The timer which I have in my stream is the countdown clock to the lift off. It's not lift off, blast off. Yeah, blast off of the rocket itself. So it's at T-1 hour 30 minutes which is remaining, and we are looking good for the launch right now. The range is supporting, the weather looks green, Cosmic Girl is ready. Although we haven't had a look at the Cosmic Girl and all those developments there yet, which is kind of which is not what Virgin used to do before. We used to get a proper view of the rocket, the cosmic girl itself. So let's hope we get to see the cosmic girl very soon.
The satellites we're building are going to be used as research demonstrators. We were able to bring a lot of our design work that we'd done on our Faraday 1 mission, including a number of the payloads and the platform design to the program. We then were able to fold that together with the work that Airbus were doing and with a lot of the requirements that DSTL had been evolving over the last few years.
DSTL are incredibly important to the technology that we are using to develop our capability over the coming years. So Prometheus 2, as the first step on that path, I think is incredibly exciting, and DSTL are front and center in terms of where we're going.
Yes, Allman Regner, I am having a great time here. Okay, so let's I can't play this music, but yeah, so we are looking good for the launch. You can see these are the payload, the customers today, and out of all of them, the Space Forge, which you can see, as the name suggests, is kind of very exciting because they are gonna make something in space. They are gonna manufacture in space and then bring it safely back to the Earth. How cool is that? And today they are going for the Forge Star 0 payload, which is going to demonstrate the re-entry capability, whether they can properly make sure the satellite and the payload or anything which actually they have manufactured is properly safe inside their protective heat shield. And that heat shield is not ablative. It's kind of what the Starship uses, right? Those tiles which are not ablative, those are radiative tiles. And finally, guys, we are having some views of the cosmic girl. You can see the red team out there. It's obviously the red team for the Virgin, but yeah, you can see the maintenance team out there. We can see most of the pipes, the wiring, the maintenance going on in the rocket. Obviously the plane does not need so much of maintenance, but yeah, so you can see finally the views of the cosmic girl. She's standing right there to make sure the rocket is properly tied up in her belly, and no, under her wing, not her belly, under her wing, and finally then she can just make sure she takes it off to the skies, and then have a little kind of, what should I say, proper a drop off in the sky. What's a nice word for a drop off? We'll have to yeah, suggest some nice words for a drop off. And then yeah, she'll drop off, and then finally the rocket, the LauncherOne, will take over from there and ignite its rocket engines, have a 27-degree steep angle, and then it will go to the space and deploy the payloads. Also, it is actually carrying multiple payloads here. It has carried multiple payloads before too, but it's always good to see a rocket which is not designed for multiple deployment of the satellites is going to do something about it. So yeah. This music is very annoying, I guess. For me, at least. Okay. Now it's gone. Hey, Infected Chris, how are you? Okay, so some quick facts about this rocket. So we will be having some so this rocket has some thrusters. I'm kind of now 80% sure that the rocket engine, the Newton 3 engine for the first stage, does not gimbal, and that is the reason why it has some thrusters, which first of all provides ullage, and the other set of thrusters provide a steep angle for the rocket to maintain an angle of attack during the burn time of the first stage, so that it reaches the space and it just does not go in horizontal direction. So yeah, there's little fun fact, and UK's first launch obviously is going to happen today via Virgin Orbit, which, you know, what other company could have done that? A British company doing something. No, it's not a British company, sorry. Virgin is not a British company, right?
MCC update here from Virgin Orbit. Our red team has approached the vehicle to do our disconnects, and that is nominal. That's normal for this phase of the mission. That means that we're fully loaded and getting ready to go. A couple of notes here on the Virgin Orbit purpose. We're on a mission to open space for everyone, and that's enabling a host of companies, research organizations, and universities to have the ability to have a space present where traditional ground launch is cost prohibitive. We support our customers to open up communication channels during natural disaster events, global and local conflicts. We're enabling the real-time monitoring of humanitarian weather and climate crises, providing infrastructure for telemedicine and global connectivity, controlling the environmental impact of production, and preventing illegal trafficking and smuggling. We're really proud of our customers' work, and we're grateful to be a small part of it. We're going to bring up a couple of graphics now and give you some information about our actual launch platform that we're using today. The first one we're going to look at is Cosmic Girl. Cosmic Girl is a 747-400, and not a lot of people know, but Cosmic Girl actually was her name before she came to us. She had originally flown with Virgin Atlantic, doing a route between England and the US. She's the baddest of them all, let's admit it. LauncherOne is our launch vehicle today. She is a two-stage rocket, as I had mentioned earlier, using both RP1 as the fuel, and we have liquid oxygen on board as our oxidizer. Stick with us. We'll be right back with some more facts.
All right. No, not the music, please. Yeah. Okay. So yeah, there is that. The graphics actually had some issue there, but that guy, the sign language guy, changed, if you noticed. Okay. Hey, Mars 2028, I'd like to wish you a happy and successful new year. Thank you so much. Mars 2028, same to you, and happy new year to you all, guys who are tuning in. And I hope this 2023 is not gonna have some again some waves of COVID. That's the least, that should be the least of our concerns from now on, and I hope that is the case, and we get to see some really great progress in 2023 in spaceflight. I am sure about that.
When you're a small satellite, you're either grounded, waiting for a ride, or drifting in space for months before you get to your destination. But there is a solution: air launch. Instead of launching a big rocket from the ground, you take a 35,000-foot shortcut straight towards the stratosphere. That's where you launch your rocket. You can fly smaller rockets more often to more orbits for less money. It's getting everybody's attention, but it's not a new concept. The first air launch happened way back in World War I, and for 100 years since, it's been a key part of some extraordinary projects. So what's new? Well, satellites for one. They caught up by scaling down. Small, cheap satellites mean more access to space, and demand has never been higher. It's a new era. The space economy of the future will rely heavily on small satellites, pushing the need for more dedicated launches. Imagine one satellite failing in your globe-spanning constellation. It'd be like, we need to launch a replacement and we need to launch now. Only air launch can do that. Why? Well, a few reasons. First, when you build a launch pad, cram it full of electronics, and set it on fire with a rocket engine, it takes a while to fix between launches. And to keep us safe back on Earth, under every launch is a no-go restricted zone. So if Weekend Warrior Willie finds himself sailing past that line, the whole mission could be scrubbed. This no-go box is smaller and farther from people when you launch from the air. Oh, and don't forget Mother Nature. Thankfully, the weather is better above the clouds. Cause congestion for ground launches. Thousands of satellites to space in the next few years. Without air launch, the math big. It's democratizing space. So the question is no longer, how am I going to get there? It's, where do I want to go?
That is, you won't be getting one free here.
Welcome back. I'd like to recap some of our previous launches here at Virgin.
Here's actually the thing here is that we need
for each one as well, and we've implemented in everything that you've seen here tonight, ready for us to launch for the first time in your first launch out of the US. So thank you for those previous launches. They've been so exciting. Yeah. And now it's our turn. But why are we here? Why are we launching from the UK? Well, we actually build a large majority of the world's small satellites here in the UK, but up until tonight, we have never been able to launch them. So with Virgin Orbit, we are now able to access space and be the gateway to space for not just the UK, but also for Europe. And that means a lot to a local economy like Cornwall. And for Cornwall, it means that we can bring jobs, we can grow and diversify the economy, and my favorite bit, we can inspire an entire generation of new people into the space realm. We're so excited and we're so happy to be launching with Virgin Orbit here. And I think we're going to talk about some of the future spaceports that you have coming up.
Yeah, let's go ahead and take a look at this launch recap video for now.
and then the engine ignition. So yeah, the thrusters are needed so that the fuel is down to the bottom of the engines and not just flowing around. So yeah, there's that. We are looking good with, yeah, thanks for confirming, File Flyer. We are right now T-1 hour 15 minutes from the launch. And the Cosmic Gull is also getting ready for the launch at 10:01 p.m. GMT, which is very near now, around just 20 minutes from the launch, from the takeoff to happen. The red team is there to make sure the rocket is fully fueled. So one more thing which is very different here is that once you take off, there is nothing called topping off of the those fuel tanks. The topping off of the fuel tanks happen in the normal rocket launch, wherein the boil off happens because they use the cryogenic fuels, and then they just top it off so that the amount of fuel remains the same. But that is not the case here. And also just look at this graphic. This graphic is a very interesting one because it shows us what is the characteristics, what is the status of the LauncherOne. Right now you can see the fuel as well as the oxygen is at 100% in both the stages, which means right now the topping off it's happening. But once the rocket the Cosmic Gull takes off, then nothing's gonna happen. So it is on its own. It has its own mechanisms to make sure that the boil off is not so much. So yeah, there's that.
Welcome back. Quick update from the Mission Control Center here. As I had mentioned earlier, our red team have approached the vehicle for all of the fuel line disconnects and the data disconnects as well. Another thing that we have checked since we were last on screen was all of our data communications to our downrange stations. We'll talk a little bit about the ground stations a little bit later, but we are confirming that all of the dishes that will receive the data from the rocket during its flight today are online, and we are still go for launch. You may be hearing on the mission control chatter the talk of an LCC, that's our launch commit criteria. We are currently working through all of our console permissions to hear all the go for flights from all of those departments. So stick with us. We'll be back in a minute.
Wow. Okay. So that's a good update from the MCC, as they call it. MCC is nothing but Mission Control Center. So yeah, there's that. And right now what you are seeing is the mission patch for this mission, and various aspects of the mission patch. But yeah, okay. All right, so that's what I was saying, that we are looking good for the launch. There are the live views. You can see the people are actually getting off now, because it's very near for the rocket, sorry, the Cosmic Girl to take off. 17 minutes left for that, from the takeoff to happen, and then obviously uh, the Cosmic Girl needs to, crawl on the runway too for some times, so they need to have that buffer too. And obviously Cosmic Girl will not turn on the engines when the jet engines when the people are working near it. So right now what is happening actually is everything is done. Right now what is happening is this, just packing off all the things which is not needed, so disconnecting the so kind of yeah, kind of like that. So those the windows which you are seeing in there, nobody is sitting inside. Those are not for the seats, not for the passengers, because yes, nobody is sitting inside there. I think only 2 pilots out there, if I'm not wrong. Not so sure about it, but only 2 humans on board to make sure that the Cosmic Girl lifts off. Not, I don't think so there is a mission control or some supports team inside the, not so sure. Actually I don't know here, but I don't think so they have a support team here. But yeah, now they are playing good music, so yeah. Yes, March 2028, you are absolutely right about all those things. The UK is hosting this launch. It's not like UK is what should I say, making sure UK has done everything and UK is launching it. UK is hosting this launch. So first launch from the UK means that UK is hosting this launch. And right now you could see those engines, those marking on the engines were starting. So the jet engines are starting to idle now, and we will definitely see the lift off, the takeoff very soon. But before that, let's just quickly recap, the flight profile for this Cosmic Girl. So this one is, yeah, here you go. This is going to be the flight profile for the Cosmic Girl. We will be having it will take a have a takeoff from the Cornwall airport in a nuke way, then it will follow this path, and once it is in this region, it will go in this kind of a circle kind of a thing, and once it completes one circle, after that,
advise you started number 3 engine on Cosmic Girl.
okay, they are starting the Cosmic Girl. So after that, if it completes one circle, it will come to this point, drop the LauncherOne. The launcher will go to its own way. The Cosmic Girl will take a U-turn again and then come back to the airport. So this is going to be the flight profile for this launch.
LCC on control room. LCCs are go for takeoff.
Base copies.
Yes, Louis Smith. If I'm not wrong, there is one startup which is going to launch from the UK. It has not. I'm just missing the name of that one startup. But yes, there are vertical launch pads being built in UK too.
SMA to LDLC on control. I'm going to take over the PTZ camera while we do takeoff, or while we roll out for takeoff. LD on control room. SMA, please repeat. I'm going to take over the PTZ camera for takeoff and roll. Roll for takeoff. Thank you.
So some
Welcome
update.
back, everyone, and I appreciate you sticking with us as I give you another pronunciation and linguistics lesson on the difference between Australian pronunciation and American. We're actually going to take a look at our flight path now. Quick MCC update. We are go for takeoff. That was just called about 30 seconds ago. So we're going to bring our graphic up that shows the actual flight path that Cosmic Girl will take after she takes off from Spaceport Cornwall. Once that's come off, you'll see that she'll track over the water there, taking off in a westerly direction out towards Ireland, and is going very close to counties Kerry and Cork. Then she'll take a left-hand turn and go into what we call our racetrack. And as you can see, it's aptly named because of the shape. We do two passes in the racetrack. The first one is the cold pass, and that's essentially where we're doing a lot of checks on the aircraft, the rocket, the prevailing winds, and the weather. And then we go into what we call our hot pass, and that's where LauncherOne goes onto its own battery power and switches to autonomous mode. When we're getting very close to the drop point, our pilots will pull into the aircraft pull-up maneuver. You'll hear on the MCC audio the words release, release, release that will come from the pilots. The rocket will drop on its way to space, and Cosmic Girl will come home to Cornwall. Special shout out to our airspace support in this region of the world from the UK and from Eurocontrol, as well as authorities in Ireland, Portugal, Spain, and France. Stay with us. We'll be back in a moment.
And let's have a little bit of a chat about who's on board Cosmic Girl today. We're so lucky to have two pilots and two launch engineers who are incredibly talented and well-versed in Cosmic Girl and this incredible launch that we're about to see.
All right, so there are two pilots.
We'll talk about our two pilots
launching.
first. We have Matthew Stannard, or Stanny, as he likes to be known, our RAF test pilot who's on secondment from the RAF over to Virgin Orbit. Joining him in the cockpit is Chief Pilot Eric Bippert. The two of them are an incredible team, and we know they're going to do an amazing job for us tonight up above the Atlantic Ocean. Joining them in the back, we have two launch engineers. We have Dale Alexander, and we also have Bryce Schaefer. These four have been amazing. We've really got to know them here in Cornwall. They've been doing test flights around the county, as well as getting into the schools and really inspiring the local school children about maybe becoming a pilot or a launch engineer or working with rockets. So the whole community is definitely cheering them on down here in Cornwall tonight. I think we'll leave it there for a moment and we'll watch Cosmic Girl as she hopefully starts to make her way around the airfield.
So guys, Cosmic Girl is getting ready for the takeoff. 7 minutes are left. 8 minutes are left until the takeoff happens. The engine checks are done. You can see the engines are kind of idling, if you can see that. Right now the Cosmic Girl is very excited to finally take off, and you can see those checks of the rudder of the Cosmic Girl. Did you see that? Flapping the wings, kind of, right? Before the takeoff happens, just to check. And then the flaps check will also happen. These are just some, and the Cosmic Girl comes to power. Are those engines noises? We'll get to know that very soon, because it's just 7 minutes from the takeoff now. Things are looking great, and Cosmic Girl is very excited. I'm so sure about that. Everyone is excited. Finally, first launch from UK, right? People are away. We're gonna see it roll over soon. And we can see those engines coming to full thrust now. Not full thrust, but still some thrust. Hey, it's happening, guys. Jennifer, that is not the case here. This is not a twin jet with rocket centered like on the Virgin Galactic website. This Virgin Galactic is very different from the Virgin Orbit. The stick which is actually protruding out of this plane is the rocket itself. So basically what happens is, this Cosmic Girl itself had this plane. Why was it selected? Because it was engineered in such a way that it can carry extra weight in one of its wing, because it was engineered to carry those newly made or or other engines which needs to get some repair. So it was that wing was actually designed to carry some extra weight of the jet engine. So it was then finally modified to have a rocket under the wing of one of its wings, basically. So you can see that white stick kind of thing which is protruding out of the plane, that itself is a rocket. So Virgin Galactic is totally different from the Virgin Orbit. Virgin Orbit is basically a company which reaches the orbit. Virgin Galactic is more like a space tourism kind of a thing. It just have there you go, guys. Finally, Cosmic Girl is off.
Control, be advised, Cosmic Girl's taxiing.
It is taxiing finally. Okay, and I'm telling you guys, when this this plane will take off now, then also you will have some chills. And this is the first time I am seeing a night takeoff of the rocket from the Virgin's point of view, basically. Sound is gone, not from my side though. Okay. I don't want the music, please. Please take. We want those engine noises. Okay, let's just see. There you go, the cosmic girl ready to take off. 4 minutes until takeoff left now. Just, looking at a plane taking off at a night and you are not sitting inside of it itself is a treat to watch. I can just look at this all the way. She's very delicate and she's very graceful, I must say that. You will see once it lifts off. And there you go. Engine noises. Jennifer, I am too. Kind of. My excitement is kind of same. So finally, guys, okay, you can see it is going to the final runway now, and they need to have this night vision on, obviously, because we can't see the plane unless unless. So yeah, this is happening, but please shut down the music now. Final runway? You bet it. 1 minute left until takeoff. 2 minutes to be precise. 1 minute 30 seconds. All right, is coming into the right runway. We are looking good. All right. We can't see the plane right now. We can see her for sure. We can see the speed of the plane itself right now. It's 17 miles an hour. Just taxiing on the runway. Hey there, Pratim. Welcome to the stream. Yes, exactly. March 2028. I don't know why they are playing this
As you can
electronic
see
music.
on our visuals right now, Cosmic Girl is taxiing. Like I had said earlier, we had cleared all of our launch commit criteria and cleared for takeoff. Our ground crew had cleared the area, and our pilots are ready for takeoff. So we're just positioning ourselves for wheels up, still planned in the next minute or two.
All right. You will see, Raymond. Don't worry about it. Takeoff is gonna happen, and you would love it. I am not so sure how would it look like in the night, but in the day when it used to happen, was magnificent.
As Natalie had said earlier, this is our second nighttime takeoff. Our last mission was also a nighttime. and some folks in the area of Cornwall and also the counties I mentioned earlier in the south part of Ireland may have noticed in the last couple of weeks Cosmic Girl making some practice
and she's
runs
going off, guys.
off the coast.
You can see that it's building up some
Cosmic
thrust.
Girl is now on the runway taking off.
Whoa, look at that go. And she is off.
We are wheels off the ground.
Whoa,
Godspeed
look at
LauncherOne,
that.
Godspeed Cosmic Girl on this historic both European and UK mission to open space for everyone.
Cosmic Girl is off. Now we have T-minus 50, so Cosmic Girl has 51 minutes for it to come to its launch position.
As I mentioned earlier on the flight path description, Cosmic Girl will now bank to the left and take her route, which is approximately west-southwest out over the ocean from Spaceport Cornwall.
LD Radiohead on control room, S-band lock acquired in Newquay.
Copy, S-band lock acquired in Newquay.
Up until the disconnects a few minutes ago, the data or the data that you had seen coming through any of our graphical user interfaces was coming through a umbilical connection to our ground support equipment. One of the things that makes us special as a launch provider is our agility, and we'll talk a little bit more about that later. But the bulk of our ground support equipment is mobile, meaning that some of the new aircraft we have purchased here at Virgin Orbit, being cargo aircraft, we can load a couple of rockets plus all of the ground support equipment, which includes our rocket fuel and our liquid oxygen conditioning ground support equipment, can be loaded on the aircraft itself and then transported to whichever runway can support a 747. So we unload the rockets, we mate the payloads to the front, usually through a special clean room that has been set up. We also have a mobile clean room that we can bring to different launch sites. Then it's attached to the rocket, and that can be done either inside a clean room or while it's still attached.
So
under
Jennifer,
the wing.
they won't. Maybe they'll see. Sometimes they show the landing, sometimes they don't. But we'll have to wait and see. But I am actually very excited to see how they will manage to show us the liftoff of the rocket, blast off of the rocket.
Connection there. So the idea is that we can fly to your port or your airport, your spaceport, land, roll out our ground support equipment, our payload processing facility.
So yes, do we see any onboard footage? We do see the onboard footage during the day, but not so sure what would happen during the night. And this is the graphic GUI or graphic user interface showing the status of all the parts of the rocket. So right now the fuel and the oxygen is at 100%. You can see that obviously on both the stages, because it has not used any. It is just the Cosmic Girl is taking care of this boy.
Interface here. All of our temperatures and pressures remain to be nominal. Some of the more interesting stuff you'll see is now down at the bottom of the screen, where the Cosmic Girl panel shows that she's currently a little over 300 miles per hour and steadily climbing, just gone past 12,000 feet.
Yeah, so you can see all those graphics. So 340
Cosmic Girl, of course, like any other aircraft, is captained. And that means that the captain on board in the cockpit is the person that is the authority on the vehicle. So there may be some slight changes to altitude climbing or the trajectory that Cosmic Girl uses to move out to the racetrack. And that's up to the captain. But generally what we expect to see here is that when we're in the racetrack for the cold pass, we'll be at approximately a little over 35,000 feet.
Exactly, that's what I was about to say, that the cruising altitude for the Cosmic Girl to release the LauncherOne is at around
I mentioned the
35,000
data
feet.
coming through earlier through an umbilical. Once we had disconnected from that IT trailer that's sitting on the tarmac next to Cosmic Girl, all of our data is being streamed through RF links or radio frequency links. So they're essentially a type of Wi-Fi. Our aircraft has that, so our rocket data will come up to the aircraft, and then the aircraft can transmit back to the ground, and you can see the live data that you see here on the GUI. Once the rocket is dropped, it has its own S-band transmitter. It's a relatively tried and true technology, S-band. It's the same technology that streamed the photos of the initial Apollo moon landing through the Parkes Radio Telescope in New South Wales, Australia, back before I was born. But that will be transmitting to multiple ground stations that are across the globe as we fly our trajectory to orbit. We will show some graphics a little later in the program that show the trajectory of the rocket today, as well as the ground stations that will be tracking her as she works her way to release the payloads.
So, Jennifer, the countdown which you see on your screen is not for the landing, that's for the drop-off of the rocket. So that's the time the rocket would be dropped off and the engine would be ignited. So the time to the blast off. So T minus 45 minutes until the actual rocket takes over and reaches the space. So we'll have to wait and see how things would pan out. But sorry, it's 3:40 a.m. down here and kind of sleepy here, but I'm also very excited to see this launch at night. Would be interesting to see how they would film this launch, though. They have not disappointed in the past, though, with the day launches. Not so sure about this one, but we'll have to wait and see. Okay, so can't find this on flight radar. I guess it is on the flight radar. Was not before, but it is now. You can check it. Exactly, Paul. You are right about that. It is on the flight radar. This is a good music. I don't know why that music was playing. Exactly, some baggage handler had its music at very high volume, but that was not a good music at all.
Wow, that was amazing. I had to step out and see that with my own eyes. So thank you, Chris. That was so informative as well. I'm absolutely buzzing. That was huge. And now we can't wait for rocket launch. I'm now joined in the studio by a good friend, Steve Isley, who is Vice President of Business Development from Virgin Orbit. Hi.
Hey, Mel. Yeah, I mean, what an exciting day. And I'm really pleased to introduce the Secretary of State, Grant Shapps, who's in charge of the Department for Business, Energy, and Industrial Strategy, leading an economy-wide transformation by backing enterprise and unleashing the UK as a science superpower through innovation. Grant, thank you so much for being with us here on this historic day. You've really been instrumental in helping bring launch
well, yes,
to the
Todd,
UK.
the humans inside the plane are actually risking their lives. I'm sure about that, because if something happens to the rocket, the plane goes down, and the plane goes down, then there is no escape plan, obviously.
Yeah, no, we're very excited about the launch. I mean, this is something which we've been working on for more than a decade now. As you rightly say, the UK tonight will become the first country to launch satellites from European soil, and that's been a long process involving a lot of folks, not just at Virgin, but throughout our space sector, which employs about 47,000 people. It's much bigger than most people realise. The other thing people possibly don't know is that more satellites are produced in the UK anywhere outside of California. So we're big into producing particularly the smaller and the nano satellites, the type that Virgin Orbit put into space. And so to see these 9 go up finally this evening, it's extremely exciting, and we're delighted to have backed this launch. And Cornwall could be one of 7 spaceports springing up throughout the UK. So we were excited to see this one and others developing.
And you mentioned some of the industry here in the UK. So how do you think this and future launches will really help propel the space ecosystem in the UK, including jobs? And what makes the UK such a great destination for launch and for space?
Been set.
Yeah, I mean, for a start, I think anything like a space launch just puts it front and center of people's minds. I was just watching the top of the 10 o'clock news here on the BBC, and I see they were giving this a mention and saying that the satellites are being launched right now. It brings people's attention to it. So if you're a youngster and you're watching this tonight or you're catching up on it tomorrow, you'll be understanding that space launches are something that happen from the UK. I think that's incredibly important. It brings more people into the business. You asked the sensible question of why the UK. Well, it happens that particularly for the type of satellites which are increasingly getting launched, a lot of these smaller satellites, they've gone from about 1% of the market to 11%. And we think that over the next decade or so, there'll be huge opportunities, probably about £15 billion worth of launches of these smaller satellites. The UK happens to have the right location, in other words, geographically. We've got the right science with, 7 of the world's top 20 universities, and we've got the right industry combined with government to help all of those things stack up and ensure these launches can happen. And I know that from personal experience because both in my current job as business secretary, but also my previous job as the transport secretary, I've tracked and worked on this launch. I've been down to Newquay in Cornwall. I actually brought over the rocket for the G7 last year to Cornwall. So we've had a lot of, to get these things going, you have to have a lot of different elements come together: regulatory, scientific, industry, government, all working in tandem, and that's the thing the UK's got going for it.
And we know that you have a strong love for science, and part of your platform is making Britain really a science superpower.
Yes, Louis Smith.
How do you see space launch?
It might not be a vertical, but it's a start, and actually does not matter if it's vertical or a normal launch until you have the capability to launch something to space, right? No matter how you launch it.
Of different satellites. So you've got Amber 1, that's a satellite that's built in Glasgow. You've got Prometheus 2, that's a satellite built in Hampshire. You've got Space Forge satellite that's built in Cardiff. So you see, as I go around the country here, every part of the country, every part of the United Kingdom has got a link to what's going on in Cornwall tonight. And that's incredibly, incredibly important and exciting. But as I mentioned before, not to take anything away from Virgin Orbit, because you guys have got there first with this unique launch system that has so many benefits. But we have a number of vertical spaceports being built and being planned, so 7 in total. And I'm expecting to see vertical launch from Scotland, for example, possibly later this year or next year. So this is an exciting time. It's worth a lot of jobs, not just in Cornwall there, perhaps 250 or so, but actually across the country, in the thousands, in the tens of thousands, and making the UK a great place to do space.
Yeah, and you mentioned some of the payloads on this mission, and there's some firsts. I mean, there's the first Welsh satellite, the first Omani satellite. So there's a real also international flavor in space. How important is it, one, for the UK to have its own launch and end-to-end sustainable space-based capability vis-a-vis other spacefaring nations, so as a nation leading in the space realm, and 2, really international partnerships. I mean, I know that this is important for UK, you mentioned the other launchers, but clearly space is an international cooperative industry, and so working across country lines is equally important.
That is absolutely true, and just in the autumn we signed a deal essentially with the European Space Agency. We put in, I think the figure springs to mind is over £1.8 billion. We secured 3 more British astronauts. So we're working in the international sphere, so in Europe, but also with NASA and a whole variety, and have historically done so. Kind of interestingly, though, you ask a really interesting question, because the UK is the only country in the world to more than 50 years ago have designed, built and launched its own rockets and satellites successfully into space, and then scrapped the entire launch program. Now, this was back in 1971. It's a long time ago now. It was kind of a surprising thing to do, given many other countries or other locations continued or have got into the space race since then. I think the big thing that's changed is the commercialization of space ever since, though, because I was just looking back. You only have to go back to 2019, and there are only about 500 satellites launched globally. But in 2021, so just a couple of years later, there were 1,900 satellites launched. So you can see this is a massively growing market, particularly these smaller nano satellites, some of which are no bigger than a shoebox, that the United Kingdom really has great speciality in, as well as some of the bigger ones, which we've always hear. So there's a big market, and we want to work globally. We want to do that, but we also think that we can grab probably as much as 30% of the launch market on these smaller satellites, which is something we're very keen to do.
I think that's absolutely right. I mean, the UK has all the pieces to the puzzle. You've got all the satellite manufacturers, you've got incredible universities, you have the logistics, and now you have the launch capability. So really, you have this end-to-end,
no worries, WWHP. If you couldn't make a donation, but what you can instead do is maybe share it and subscribe to the channel. That would also help if you can't, if you weren't able to do that.
Really, that we're pleased to be your partner on this journey and help make that a reality. Maybe shift.
Well, thanks very much. It's great to hear you say that, because folks won't know, but we generate about £16.5 billion from space income each year in this country, and it's only set to grow. And we're going to work internationally to make that happen. And having this launch capability from British soil clearly puts us front and center of that.
Absolutely. And finally, I think so people know that you're a pilot yourself. So as you know, captive carry is happening. Our pilots are going on this journey, going forward. Maybe you could talk a little bit about your experience as a pilot. Just what's going through your mind? Like, what is your mental state right now, and how exciting is this for the people that are really on the front lines here of this launch?
Well, obviously I offered Virgin Orbit the opportunity to use me as the pilot, and I'm just kidding. I think everyone who flies, everyone with a pilot's license knows that the thing that you're always doing before a flight is you going through the pre-flight checks in your mind, and then after that you go through the whole sequence of thinking through the flight. I visualize the flights that I take in advance, and I know that the captain will be doing exactly that. Incredibly experienced RAF pilot flying the aircraft this evening. He will have run through this, has done it, of course, in reality as well, so it's not just a sort of in principle thing. And that visualization, I always find as a pilot, really helps the process of flying. And of course, on a mission as important as this, I know that is the work that will have been going on in advance.
Yeah, and we're of course rooting for our pilots, rooting for our team. I know the country is behind this mission. We're excited to be here in the UK. Grant, in the few seconds we have left, is there anything else you'd like to tell our viewers maybe about this mission, or about some other insights, some parting words, if you will?
Well, look, when I came down to Newquay, and we brought over the rocket last year. Actually, it was a replica of the rocket last year. Some people said to me at the time, this is all fine, but actually, is this just a static display? Is it really going to happen? Is it really going to happen from the UK? And, collectively, and you guys in particular, have proved that the answer is definitively yes. The aircraft's in the sky. I think in, in 48 minutes or so, we're looking for the drop. So, I just want to say a big thank you to everyone. And it's now thousands of people who've been involved in getting this mission up and running. There were any number of things which could have stopped it. And the first time you do something, particularly from somewhere new, there are these satellites. And well done to you folks for making this happen. And tonight, all eyes are on the United Kingdom launching these satellites.
All right, Secretary of State Grant Shapps, thank you so much again for your continued support. Thank you for your leadership, and we look forward to continuing the partnership.
Thank you.
All right, so that was some information on how UK really appreciates what is actually happening today. And yes, it's a big deal for them, because as you know, as he said, we have so many space startups, so many satellites coming in from the UK and Europe in total, but nah, we don't have a proper launch capability to launch those satellites for the UK people. So it's a big deal. And it's a right step in the right direction for making sure the UK can also launch. And obviously they are looking in for the vertical launch pads, also building 6 of them. And we need to you know, support them basically. So right now things are looking good. We are T minus 46 minutes from the drop. The Cosmic Girl is already in the air. She has taken off, going to the sea. Which sea is there near the UK? Not so sure, but yeah, she's going near the sea. Have a certain it will do a racetrack maneuver. That's what they call it, racetrack maneuver. It will have a cold pass and then a hot pass. In the cold pass, it will just make sure everything is all right, everything is up and running, some checks and everything. Once that is done, and then the hot pass will happen. In the hot pass, it will do a circle, come to a point, and then finally drop it off. So we are not seeing the stats from um, the plane itself. So if any one of you is tracking the plane, can you also share us the altitudes, if it also is shown in that flight radar thing? So we'll have to wait and see how the things would look like in the case of dropping it off perspective, because how they will film it, the main thing. Again, it's night time, and how would they film it is a big question. So we'll have to wait and see. But other than that, there are 9 payloads on board, and from different startups and different things across UK. The total payload capacity is around 100 kg. It is going to a sun synchronous orbit, around 550 kilometers sun synchronous orbit, which is a polar orbit. And yes, the UK has its own UK is not so suited for the polar orbits launch, but since this is a plane launch, so I guess it's all right. Okay, so current altitude is 32,000 feet. Okay, all right. So actually the cruising altitude for this, it will be around 32,000 only right now. When that hot pass will happen, right? Once that it performs a racetrack maneuver, cold pass is done, and then the hot pass will happen. Then it will just have a angle of attack of around 27 or 30 degrees or so, and then it will reach to 35,000, 37,000 feet, and then release. That release altitude is actually determined by the pilot in accordance to the wind direction and the weather in there. So the pilot decides what should be the drop off altitude, but it's usually around 35,000 feet. Kind of, you can say a minimum is around 35,000 only, but then obviously it can change. So it's looking good. Hopefully Cosmic Girl never disappoints. Let me just tell you that. But talking about the LauncherOne rocket, yeah, this is the graphic of the LauncherOne rocket. So you can see the status of it. The fuels are at 100%. The temperature is holding at a good temperature, but the graphic also shows that the LauncherOne rocket is a 2-stage rocket. So the first stage is powered by a Newton 3 engine, which you can see there. And in the first stage itself, it has some thrusters, 2 type of thrusters. First thrusters is a kind of an large motor, which is used to make sure the fuel is all at the bottom once the rocket engine starts. And the other thruster is to maintain the angle of attack. you need to have a certain angle of attack so that the rocket is always pointing upwards and reaches to the space and just don't not fall to the ground, right? So yeah, there's that. And then the second stage is also powered, not also, but it's powered by Newton 4 engine, but is also powered by the same fuel, RP1 and LOX. We are unsure about the cycle of these engines, but these are pump fed engines, that we all know. But we don't know, we are not sure about the cycle of the engines, because the version has been a little bit secretive about the technology of their engines. So yeah, so here you can see the stats of the Cosmic Girl. Also the speed is around 382 miles an hour. 30,000 is the altitude, and yes, it is cruising around that altitude right now. And also there is a pressure palette, nitrogen and helium, which you can, so the amount of fuel left in those pressure palette also, and you can see the amount of people which actually came to view this launch. So I guess not so sure whether this is the view where you can see the Cosmic Girl actually taking off. Yes, Robert. I can follow it on flight radar, but I'm not because my phone is not charged up right now and I can't change the screen here. It's charging, and once it switches on, then I will track it down. But it's 39 minutes from the launch. Everything is looking good. So you can also see the flight timeline here. So the Cosmic Girl has taken off, and right now it is at captive carry. And then the LauncherOne timeline is there. The drop, the stage 1 ignition, the stage 1 cutoff, the stage separation, stage 2 ignition, fairing separation, stage 2 cutoff, stage 2 second burn, and then the stage 2 cutoff again, and then the payload deployment. So this stage 2 second cutoff is needed so that it can actually circularize the orbit. So yes, the Newton 4 engine has a restart capability. So guys, if you are new to this channel, let me just tell you that on this channel we do live streams of the rocket launches, the space events, and all those things that happen in the space industry. I try to give my own commentary, which is very informational. That's what people say. So if you are into space, rockets, and all those stuffs, please hit that subscribe button. You won't regret it. And if you are not, then also it's a very good place to watch the launches, because then you can just enjoy the beauty of a liftoff when the rocket lifts off from the pad. So yeah, and if you want to support me, guys, do support me by becoming a member or a Patreon. Link is down in the description, and the super chats are always enabled for one-time fun. All right. All right. 2000 tickets were sold. All right. Correct word, but yeah, you got my point. And then the obviously the efficiency is also not so good, but again it is actually better than the sea level because you are
Welcome back,
launching
everyone.
in
This is
air.
sometimes thought of as kind of the more quiet part of our mission. Obviously, we haven't dropped the rocket yet. When we light that candle, things are going to happen very, very quickly. For those that have been watching our GUI, you can see that all of our fuels are nominal. But one thing that we are watching, keeping a close eye on, is our payload adapter fairing temperature. During the climb, the aircraft right now is at, I believe, just over 30,000 feet, which is nominal. And during the climb, we were moving through the clouds in a storm cell. One thing we like to do during our captive carry is actually do a little fin wiggle to make sure that if there is any icing that occurs on the rocket during captive carry, we're able to break that away. We detected no icing during the captive carry up to this point, but we did that little execution anyway, and that all worked nominal. We are tracking nominally. I keep saying nominal, which is a good thing. We are tracking nominally on our flight path out towards the racetrack right now. We'll be back in a moment.
These sign language guys are, oh god, so much trained, you know. They need to just translate it in the live at the live TV and make all those. First of all, remember the words which a person said, and then to convert those words into the sign language, do those signs. And sometimes it might happen that they don't know what is the sign, because this rocket, this launch tower, the payload, do we have words for these in sign language? How do they come? I don't know. I'm not so sure. So yeah, it's a nice touch that they have added sign language guy here. So we yeah, another 29 minutes until the drop off. And he actually, you know, pointed out to a very critical what should I say, thing about the payload fairing temperature and that ice wiggle which needs to happen. So hey Mars 2028, thank you so much for that too. I predict ISRO will have a good year. Do you agree? Yep, I do agree, because Chandrayaan 3 should be launching this year. The Gaganyaan mission, the test flight for that mission should be launching, and Aditya L1. So there are a couple of space missions, exciting space missions, which are going to happen this year. So we'll have to. I'm pretty excited about it. So let's see what we actually get to see. Plane is reaching the race circuit. Okay, comedy Shane, that's a good part. Oh, wildflower. Okay, that's a nice fact. Ah, so it's a nice fact, wildflower. So in army, do they teach sign language or what? Yeah, they do teach. Yeah, kind of needed in the fights, but yeah. So I was talking about that temperature. Okay, yeah.
Hi everyone, welcome back. I have a very special guest with us, Colonel Davis, who is the director of the Office of Space Launch at the NRO. And Colonel Davis is joining us here today on behalf of one of the payloads that is flying with the launch today. And so we're really excited to have you. Thanks for joining us.
No, thanks for the opportunity. It's absolutely great to be here and play a small role in this truly historic launch.
So when you and your colleagues heard about, at the NRO, first heard about the possibility of launching out of the UK, what did you think?
Yeah, it was absolute excitement. You know, since the very existence of the NRO started over 60 years ago, we've really taken great pride in, you know, how innovative, how we like to advance the state of the art and the art of the possibility when it comes to operating in space. This was just really another one of those opportunities to do something brand new, to do something exciting, and that's all really truly in our DNA.
And so, of course, I mean, there are other launch sites, historic launch sites in the USA, like Cape Canaveral, Vandenberg. What do you see as the value of having additional launch sites, in particular out of the United States?
Yeah, anytime that we can go to any different launch site, any different launch capability, that adds diversity to the portfolio of launch solutions that we as the NRO launch providers are able to give our customer set. That enables them to be able to not hinder what they're doing with their technologies and really opens up the aperture for more advancement and more ability to do what we need to do in space.
And so do you see then there being potential advantage or value to geographical spread, particularly when you think about launching internationally?
Oh, no doubt. And that's just, again, the diversity that we're talking about. And anytime that we're not committed to any one or two launch sites, that just it enables us to do different things, to do better things from wherever we need to do.
Absolutely. And yeah, we agree. We think there's definitely different opportunities to provide access to different orbits and mission capabilities. internationally. So moving to another topic, there's that phrase responsive launch, responsive space, and it's a pretty exciting term in the national security world in particular. What do those terms mean to you, and how is that important to your mission?
Yeah, responsive launch from my perspective is really being able to be responsive to my satellite customers' needs, to be able to deliver a launch solution when they need it, where they need it, how they need it, unconstrained. So having vertical launch, having horizontal launch, all of those things, add additional toolbox, adds to my toolkit that I can take to my customer set.
Yeah, absolutely. And then, of course, launching on demand potentially would be a whole nother benefit within a 24-hour period or so, which is something Virgin Orbit is trying to accomplish. Another question would be, a lot of what you and your NRO colleagues have talked about when discussing this mission in particular is the value of the partnership. I think the international partnership in particular with the UK RAF. With all that's going on in the world and in space right now, both in the areas of conflict and in times of peace, what do you see as the start of international partnerships and interoperability between the US, the UK, and potentially other partners? What are those benefits there?
Yeah, you absolutely nailed it. The agility, partnership, and interoperability were the three big things for us with this mission. You talked about partnership and interoperability there. No doubt, if you look at the logo for this mission, it screams partnership. You've got NRO, U.S. Space Force, UK Space Agency, RAF. The list goes on and on and on, not to mention our industry partners. So yeah, partnership was a key part of this entire mission for
nice
us.
facts, Wildflower. Appreciate it. I didn't know about all those things.
But we don't exist unless we put capability on orbit. Right. And as the primary rideshare for this mission, we're here. I have a job to get capability on orbit. And with these primary payloads that we're working with the UK MOD and DSTL, that's the whole goal, is to be able to demonstrate our allied interoperability with that data sharing across our partners in this, as you mentioned, incredibly dynamic and quite frankly dangerous space environment that we're dealing with today.
So you definitely see that this type of partnership is something that will be valued going forward, and more such missions will likely be accomplished then in the future.
Well, yeah. I mean, anytime. Who knows what tomorrow looks like, right? But again, anytime I can provide unique solutions, any other kind of launch solutions to my customer set, that's attractive to them. So yeah, we certainly hope to. Yep. This has been the Cornwall community here, the Cornwall Spaceport, the Newquay community have just been absolutely fantastic. We were in a taxi the last time we were down here, and they were like, "Oh, are you out here for the launch? That's so exciting!" The community is just really embracing, and it's fun to be a part of that.
Yeah, exactly. I mean, especially being a historical first here, I mean, it really means something to be part of it. So it is, you can feel that excitement, whether it's in the taxi cab or at the launch site. Yeah. And then finally, the other major element of the partnership that often gets discussed is between government and commercial industry. How is the ability to leverage commercial industry in particular, and in order to tap into new capabilities, change the way that you and your colleagues work and think about missions?
Well, it enables us to really unlock the innovation. That we are all about advancing technology and innovating. Nobody does that better, more efficiently, quicker than the commercial environment. So anytime that we on the government side are able to put constructs in place, like the contract that we used to acquire this particular launch service, that really harnesses the energy and the power that's in that commercial industry, so we can work together better and ultimately advance our U.S. and allied capabilities.
Yeah, I can agree more, of course, on the commercial side. But I mean, and we likewise appreciate the partnerships with government entities that are also encouraging and supporting new technologies to come to the market. So it definitely is, it's a symbiotic relationship that I think fosters and supports both sides. So, Colonel Davis, it's really been a pleasure having you here today, and we thank you for coming down to Cornwall. Do you have any final thoughts or words you'd like to say as we get ready for the launch?
No, again, thank you. Thanks to Mel, who's been the host most of today on this, her and her team, and then the Virgin Orbit and Virgin Orbit National Systems teams have just been fantastic to partner with on this particular mission. And I personally have been really proud to just play a small role in it. So thanks very much.
Thank you. All right, back to you guys.
Okay, so second stage give more light than the first stage. More light? I don't think so. The second stage won't give. Actually, the second stage will work in vacuum, so that light which you are talking about is gonna get diffused and get expanded in space. So it would be difficult to spot the second stage. The first stage, yeah, might be if the clouds support you. Then, okay. So what is this? Are they? I guess it's now in the race circuit course. So T minus 17 minutes from the launch left. So yeah, I think it's in the race circuit course. Gonna it is going to do a cold pass right now, and yes, it is doing that. After that, it's gonna do a hot pass and then finally drop, release. That's what you're gonna hear, and then the pilot pushes that big red button, and then it GR19 1977. Shout out to your son Ben. I hope he's enjoying it. We are right now T minus 14 minutes from the actual drop off, which is going to happen. I'm sure he has not seen rocket launch from a plane. So it's an exciting
Welcome
thing
back,
to see.
everyone. As you can see from the data that we're just showing on our graphical user interface, all of our levels are still nominal. We're watching, as I had mentioned earlier, we're watching that payload adaptive temperature, but that is still doing totally fine for this phase of the flight. For those folks that have been watching our 3D map, which we'll bring up now, you'll notice that we did fly just south of the county of Cork in Ireland. We've taken our left-hand turn and now we're in our racetrack that I had mentioned earlier. So we'll be moving into our coal pass in just a moment. We are still on track for our previously advertised drop time. So yeah, stay with us.
So that's a good T minus 12 minutes. Okay, so the time has kind of changed. I'll just update that countdown there. Yeah, March 2028. Actually, the thing with the rocket launches is, especially where I live, is that there are so many launches outside of here that the time of the launches is around this time only, 4:30 a.m., 5 a.m. and I need to just wake up all the night, do the commentary for, and I enjoy that, not a thing, but obviously I also feel sleepy, so sometimes the energy gets low, so yeah, pardon me for that. Something, you know, we don't appreciate it much, but it has had its appreciation, you know.
Welcome back,
at its
everyone.
time.
You already heard about the Prometheus payload that is one of our payloads that we're taking to space today. I want to tell you a little bit more about a few more of the ride shares that we have on board. The first one there is the IOD-3 Amber, or commonly known as the IOD, which is developed by the Satellite Applications Catapult and Horizon Technologies and is built by AAC Clyde Space, all based in the United Kingdom. IOD-3 is expected to be the first of more than 20 Amber satellites to provide space-based maritime domain awareness data to users. Another one is CIRC, or the Coordinated Ionospheric
So
Reconstruction
people
CubeSat
talking,
Experiment.
asking where to look. Let me just, show you the map here. So this is the racetrack which the aircraft is moving in here right now. So maybe you can even look at the flight radar, and you would actually get to see where is the location. So this is the map. This is not the viewing map, but this is the flight profile. So now just have some guesses from where you live and where you should look according to this map. So, and maybe have some use of the flight radar to track the cosmic girl and see where do you have to look actually.
Terminal count has been given the all clear. The terminal count is the portion when the rocket goes into an autonomous mode. We did have some questions on the YouTube stream that I want to address. Some folks saying this is actually the second launch after Wallace and Gromit went to the moon for cheese. Thank you very much for that. And also the use of Fahrenheit versus Celsius. Typically in the aerospace world, we use imperial units over metric units. I think that's all I got for the moment. Like I said, we're moving into the cold pass, and things are about to get very exciting. So please stay with us.
Okay, you can see yes, this is the flight radar. This is the flight tracking, and yes, the cold pass is gonna get complete very soon, and then we will see how the plane would look like. I don't think so it would even need to do another pass, because I guess it's just we have only T-7 minutes left first of all, and if everything is all good, then why do you need to take another circle, right? So yeah, some escort planes when it was a day launch. I know that because I have seen that, but not so sure about this one.
But before that, we want to talk a little bit about the mission name, Start Me Up, which is named after the iconic British rock band's record, Start Me Up, that was released by Virgin Records in 1981. I can't think of a better name for the mission, for a starting up launch out of the UK. But let's hear a little bit more from a familiar face, Sir Richard Branson.
Start Me Up. I can't think of a more perfect name for Virgin Orbit's first launch from Spaceport Cornwall than the UK's first launch and the start of an important and exciting new capability. I first heard the Rolling Stones when I was at school, and their songs have been in my head ever since. As a nervous teenager, armed with a tape recorder bigger than me, I interviewed Mick Jagger for Student magazine. And years later, we tried to sign the band, and years after that, we finally managed to bring the Stones to Virgin Records, and they helped make us the biggest independent record label in the world. I remember hearing Keith Richards kick off Start Me Up when we promoted the Stones comeback tour in 2012. A decade on, they're still going strong, and I've loved spending time with them over the years, even if Ronnie Wood beats me at poker and pool. One of the most wonderful parts of Virgin Orbit's missions has been the opportunity to bring the Virgin family together, not least by honouring a Virgin Records artist with each launch. And this should be the most thrilling one yet. Congratulations and good luck to all involved in this launch in Cornwall, the UK and worldwide. Like the song says, once we start it up, we will never stop.
Wow, okay, so WWHB, you finally figured it out. Thank you so much for that 5, man. Really appreciate it. So yes, guys, it's happening now. We are T-4 minutes, only 4 minutes left from the launch and the drop actually, and we are looking good for this drop from this cold pass only. So we'll have to wait and see how the things would look like, but I don't think so we would get some views of the onboard footage. I am hoping that we do get some, but I don't think so. So T-3 minutes 30 seconds from the drop, everything is looking good. So now what will happen is after this, once it passes a certain point, it will just point itself up in around 27 to 30 degrees in incline, and then it will just maximize its thrust, boost up to the full throttle, and gain as much as altitude as possible, typically around 35,000 feet. Once that is reached, the release will happen. With the pilot will do that. The rocket, the LauncherOne rocket, will have a free fall for around 4 seconds, and after that some thrusters will ignite first. Before 2 seconds the thrusters will ignite. After that the engine will ignite. Those thrusters will ensure that all the fuel is at the bottom and the rocket engine is not devoid of fuel. So after that it will just cruise. The rocket will cruise itself towards the space. So that's what's going to happen. So it's T minus 2 minutes 10 seconds remaining, and I am actually very excited now. I hope we get to see some footage, but let's see what we get to see. But yeah, is that it's kind of an exciting, right? It's kind of exciting to see all those things. So yeah, do we get a live video from the feed from the launch, Steve? I hope so. We do get it, but don't think so. Let's see. T minus 1 minute 30 seconds remaining. Everything is going as per the plan, guys. Okay, this is happening. I hope we get to hear the pilot commentary also, because that used to happen before, if they have not messed up the stream. So T minus 1 minute 15 seconds 10 seconds remaining. Okay, this is happening finally. T minus 60 seconds. God, tell us please, pilot commentary is must here. So 570, you can see the speed is increasing. The altitude is still at 30,000 feet. It will increase, or maybe the pilot is just going to take a U-turn. Okay, so the altitude is also increasing. T minus 30 seconds. We'll have to wait and see. From the GUIs, T minus 15 seconds remaining. This is not a release altitude. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. No release. So yeah, the fuel is at 100%. We'll have to wait and see. I guess the pilot did have some decision to make, and he made a decision to not release it. So it's drop ready right now. Okay, so it can happen anytime. So you can kind of say that it is kind of, the launch is imminent. That's the ideal word here. The Cosmic Girl speed is 0. Okay, but the altitude, yeah, it is increasing, guys, and yes, the fuel is decreasing, which means it has been released, and we did not see any views. So you can see the fuel is decreasing right now. So the rocket has been released. Okay, whoa.
Welcome back. Just a quick update from the MCC. As you can see on the screen right now, we have made it through our cold pass, and we're now working through the hot pass. The counter on the left-hand side is a little bit of a misnomer because it's really drop ready time. And I also did want to mention, you probably saw a quick camera feed that we had where the screen looked black. That's actually nominal because that was a live camera feed from the camera that's actually on the rocket underneath.
Wow,
the payload
look
fairing.
at that. It is working.
You can see now
It
this
is
is
working.
an aft camera view from the drop. So we have, it looks to be a successful ignition of the stage 1 engine as we make our way to space.
So finally we could see some onboard footage. So there you can see, guys, we have the footage from the rocket. The rocket is burning like hell right now. So this is the first stage which is burning. So it is supposed to burn for around 3 minutes or so. The max Q will also happen, and basically it has one engine as well as another thrusters. One thruster is there to make sure it preserves the angle of attack which it needs to have during the climb. So right now it is you can see the plume is kind of becoming a spark. Okay. Okay. All right. So the plume is a kind of expanding, which is supposed to happen. The color is getting changed. So yeah, right now the altitude is 5,000 feet. Sorry, the velocity is 5,000 kilometers
Like I
per
had said
second.
before, a lot
Miles per
happens
second.
very quickly after drop. You can see here that we're actually getting towards the end of our stage 1 burn. Everything is nominal so far. We've had our pitch up on the bottom, on the burn time
Stage
event
1
that you
throttle
can
down
see
commanded.
on the graphical user interface if you do have that one up. We have made it through max Q alpha, which is one of the most stressful physical moments for the rocket, very comfortably through max Q.
So we have
and
the
then
MECO,
also
guys.
through our maximum heat.
The stage separation is done, and we have the ignition on the second stage. Yes, no.
We have made it through MECO, our main engine cutoff. That is our
We
new
have
entry
ignition on the
engine shutdown is reported as nominal.
Okay. Yes, the acceleration is constant right now, so the ignition of the second stage has happened.
And if we can go back to our aft camera.
Fairing brake wire is broken.
We have stage separation.
What is broken? Fairing what? That did not sound good.
You may see dropouts in the data during the flight here. That is expected as we're switching between the different ground stations that are picking up the signal from the rocket.
This is the feed from the rocket itself, and I think this is the payload.
Switching data source to the Nuki.
Because we have lost the telemetry or
Now, as you can see, the trajectory that's being shown on the screen is no longer of Cosmic Girl because she is on her way back to
some telemetry, all right.
Spaceport Cornwall in the UK. The trajectory is now tracking LauncherOne as she makes her way down the Atlantic
Everything
Ocean
is looking
towards the
nominal
Canary
right
Islands.
now. That is good to hear. So the fairing has been separated. Everything is looking good. That's what we want to hear. You can see the fuel is 70% or so remaining, and the acceleration is increasing. So yeah.
Stage 2 trajectory nominal.
Stage 2 trajectory nominal. That means our flight path is as expected.
So guys, were you able to spot it? Did you spot it or not?
Halfway through our stage 2 burn number 1. On the GUI here, you can see in the center there, obviously the cool flame coming out the left-hand side, but you can see the fuel and the oxygen leaving the stage as it goes through the engine. Another really neat thing to see is the gimbal over on the left-hand side. The blue square with the dot in the middle shows you the position of the engine as it is steering stage 1.
Stage 2 burn nominal.
Wow, that gimbal thing I didn't know, but yeah, that is cool. That is literally
Altitude
cool.
now is looking at around about 600,000 feet.
fairing separation
approximately
will
3
happen.
miles per second.
Fairing separation is going to happen
Bus
very
voltages
soon.
for the batteries are nominal. You may have noticed that we had a lower voltage while we were in captive
Switching
carry,
data source to
and that's
Madrid.
because the power was being provided by Cosmic Girl at that point before we switched over to the rocket's internal batteries.
The telemetry is going okay, so that trajectory is not looking good. Is it just...
Stage 2 burn is a little longer than the Stage 1 burn, so this
Whoa,
might take
look.
a little while for us to get to second engine cutoff
Look at
1.
that altitude. This GUI is having some seizures. Liquid oxygen levels are... What is happening here? These are not... Signs are not looking good. See the gimbal. No, man. Nah. If the gimbal is also not just look at that. Just look at the trajectory. It is not looking good.
As I said earlier, there are points of the flight where we don't have the telemetry coming from the rocket because we are out of view of the ground stations. Our flight software folks have implemented a store and forward on our rocket, which means that when we are out of view of the ground stations, we are storing that data so that the next time we do come in view of a ground station, we can download it and
Confirm
and
target
look back
lock
through
from
it.
Madrid. Data source switch to Madrid.
Yeah.
Okay.
Our Madrid ground station has locked on to our rocket and is streaming the data now.
Let's see what do we get. I know the data ignition media. I do know that there is a switch in the data, but see the trajectory. And that
Confirm
gimbal...
signal from Maspalomas. Switching telemetry source to Maspalomas.
I hope we that was just a normal
Newton 4 shutdown initiated.
shutdown initiated. Okay. Stage 2 cutoff has happened. All right. But why this trajectory is like this? I don't understand it.
You just heard the call for a Newton 4 shutdown. Newton 4 is our stage 2 engine. So that is the completion of the first burn of our second stage.
It's working as per the plan, so that is good, but I still don't understand why the trajectory is like this. Maybe just a glitch on the computer end. What happened with the gimbal? Well,
you can see along the bottom of the screen right now, our flight timeline has been updated to show the Cosmic Girl is returning.
That was actually, I know that the GUI was having some seizures. It was showing anything, whatever it wanted to show. So yes, when the data drops happen, something it performs like that. But the main thing was this trajectory. But I guess this is how it is. So yeah, why this is happening? Because the altitude is increasing, the speed is not. Maybe that is the reason why.
So now's probably a good time to talk a little bit about our rocket profile. Like I said, once we get to drop, a lot of stuff happens very, very quickly. What you might have seen is initially after the drop, around about 5 seconds or so after the drop, because we need to make sure that our aircraft is safe and out of the way, we fire what we call our propellant settling thrusters, or our PSTs, and they're solid rocket boosters that are on the back of LauncherOne, and they give the rocket a little push forward to settle our propellants for stage 1. And then we have that main engine start, or MES, for S1. And then you saw over, I think it was about 3 minutes or so, our stage 1 burn, which, as I had said before, does most of the heavy lifting, and our main engine cutoff. Separated from stage 2, and stage 2 has to do the work for the rest of the journey. We start our second stage engine, which is the burn that just happened. And during that burn, we separate our fairings. And what that does, it opens up the pointy end of the rocket essentially through ordnance firing.
The altitude is
That
dropping
opens up
drastically though.
that section and exposes the payloads. We continue to fly under power on our second stage during that first burn, and then we'll have that cut off. And you can see the graphic on the screen right now. We again get to the coast, which is the phase that we're in right now. And we do a maneuver. We execute a maneuver called the barbecue roll. So essentially, we are rifling through the atmosphere, and what this does is it avoids one side of the stage from getting too hot and the other from getting too cold. Our rocket is covered in a spray-on foam insulator, but this is a very standard maneuver procedure that most rocket companies execute.
So right now the altitude is dropping, and I think now it has become stable. The reason is, sometimes this happens that when it is coasting towards a point, the altitude decreases. That does not mean it is not in the orbit or something like that, but it's just that it is following a certain path, and once it reaches a certain point, the engines will ignite and then circularize the orbit. So the main thing is that the dropping of altitude does not always mean that something is going wrong. So sometimes it's just a nominal thing in the orbit. That's how sometimes the orbital mechanics work.
Second engine cutoff 3. Once that's complete, we go into a phase that we call safing, and then the mission is complete.
So right now it is in the coasting phase, and the barbecue roll is going on, which is nothing but, as the name suggests, the rocket itself is rotated around its axis. So it is actually barbecued, and the heat means the thing which is barbecuing the rocket is the sun. So in space there is no protection from the sun rays, and there is nothing, as such which can protect anything from the heat. So that is the reason why sometimes when you just are having one point towards the sun and the other is not, then the point which is actually facing the sun becomes extremely hot, and the other point is extremely cold, and you don't want that imbalance of temperature during that, and that is the reason why you barbecue your rocket. So yeah, that is the thing. So we are in the coasting phase. The stage 2 cutoff has happened. The stage 2 ignition, the second stage, second engine start 2 will happen very soon.
Say how much we appreciate the folks that came out to Cornwall this evening to watch our launch. It is a historic day, obviously, for the United Kingdom, but for Eastern Europe as well. And we very much appreciate you all being here today, including those folks that have joined us on the live stream through YouTube. Thank you for being here and being part of this journey with us.
Wenfi says, how does it stop in the space to deploy the satellite? So it has those thrusters which see, trying to stop has some unique ways. In space you actually can play with physics and angular momentum. Okay, so let me just tell you, for in this case with the rocket, if you are talking about how would they stop the rotation, then yes, there are certain thrusters which initiated those rotations. Those thrusters will again kill that rotation, and then the satellites will be deployed. So that would happen. But what was I saying is that there is some unique ways in which CubeSat can actually kill its rotation. If somehow for some reason it needs to be rotated, and then you need to stop its rotation, so you can actually have a help of the conservation of angular momentum in space. So this unique thing which CubeSats do when they are in space is that when they want to kill their rotation, they have this heavy balls or some sort of things connected to the strings. They just throw them out, okay, those heavy balls, and because of that their angular momentum changes, and since the weight distribution has changed, the angular momentum gets changed, and that CubeSat rotation gets slowed down. Just simple physics. Isn't this interesting? If you have seen those experiments where 95 degrees to be precise. Most of the CubeSats prefer this orbit because of its unique properties that it covers the whole Earth. I have seen that on GUI also, and I have commented based on that uh, telemetry which was there on my screen, and I was wrong. So I'm not trusting the telemetry. So let's just hear from the mission control room only that whether people. So we are T plus. That's the time from the takeoff. T plus 1 hour. The time which you are seeing on the screen on the left hand side. On the right hand side is the time since the drop off. So T plus 22 minutes. So the stage 2 has cut off now, and right now it is going towards the point where it needs to circularize, and most of the time it is at the apoapse. So if you have played Kerbal Space Program, you know when you want to circularize the orbit. So the next burn is going to happen, which is supposed to circularize the orbit. But what they'll do is they'll go to the highest. Most of the time that this is what they do is, until unless there is some sort of constraint, they'll go coast towards the highest point of the orbit, which is the apoapse. There they'll switch on their engines and then burn for some time so that they can lift the lowest point of the orbit towards a certain height. So in orbital mechanics, what happens is when the point where you are actually providing some thrust, the opposite point, the exactly opposite point on that orbit
Control, we're gonna change the
gets a
traffic lights
lift
back to green.
or gets a lift, or goes down.
SMA concurs changing traffic light to green.
Depends on the direction of the engine. So now they would want to lift that point above the atmosphere, so and to reach the correct altitude, so they will point towards the forward direction in the engines. So this is how orbital mechanics works.
LD to SMA on control, do you copy? SMA controls on copy, go ahead. Have you let the tower know that hazardous operations have ended? No, I have not and I cannot, but I can coordinate with range 1 on FA in it. Copy. Also, did you change the traffic light? No, I did not. Sorry, we're going to green. Is it green now? Let me pull up the... It's okay, LC is working it. Okay, copy. SMA
Welcome back, everyone. This is, of course, the least interesting part of the flight. We are in S2 coast, so there's not a lot happening, and you're not probably hearing a lot of audio come from the Mission Control Center. But I did want to let you know that Cosmic Girl is only minutes away from landing. That is our primary mission, is safety here at Virgin Orbit, and we want to ensure that our flight crew and all the folks on the ground are ultimately safe at all phases of our mission. So yeah, just a quick update here from the MCC. We'll be back with more in a moment.
All right. The Cosmic Girl is about to land, that means, which is a great sign because you want the human lives to be preserved no matter what. So, yeah, we'll have to see if they can show us the landing at least. The plan, and you can see the telemetry is just has just stopped. I guess this is just a what should I say, the range issue right now. I mean, it's not in the range of the also. I don't know why when they launched they did not switch over to the pilot's commentary or do some sort of countdown or like that. We didn't even get to know when it launched. It just launched when we got to see those telemetry, actually, the fuel, the fuel level. that update.
Welcome
Cool.
back, everyone. It
Dropping in.
appears that LauncherOne has suffered an anomaly which will prevent us from making orbit for this mission.
What?
We are looking at the information and data that we have gotten, and we'll be back with you in a moment with more.
Dude. F's in the chat, guys. F's in the chat. So the telemetry was not messing up. And how did they... I'm not so sure what is happening. I'm so confused right now. Like literally confused. Was it supposed to light up at this point or what? Like literally... Dude. We appear to have an anomaly that has prevented us from reaching the orbit. We are evaluating the information. That's what is the official tweet from the Virgin orbit. But okay. I've seen the chat. First launch from the UK, you know, the first word in the rocket industry, first thing from something, first thing you have to do is very, very, very cursed. It's very rare that a thing which is done at first is successful. So it's not that obviously it's not because it launched from UK something has happened. This is purely a Virgin Orbit's issue. So does that mean the telemetry which we were getting was good? I mean, was not good, or was it correct? I am so confused right now. Let's all have a silent disco. I guess that's what we are supposed to do right now, huh? Trying to figure out what has actually happened, because whoa. Obviously they won't be able to reach the orbit now. They are evaluating the issue, but this mission is gone now, because obviously the time to relight the engines has gone, and if it has not reached the orbit, that means this is good enough proof that this mission was not a successful one today. Yes, Carl, we should be having some issues, some updates on what actually has happened, but right now the update is this only, that Actually, the funny thing is when I am now looking at the Twitter feed, they have this tweet, you know, half an hour ago that LauncherOne has once again successfully reached the Earth orbit. Our mission isn't over yet, but our congratulations to the people of UK. This is already the first ever orbital mission from British soil, an enormous achievement by space UK government and their partners in government. So this tweet is still live, and what they wanted to do is meant is LauncherOne has once again reached space. It obviously did not reach the orbit, or maybe it has reached the orbit, but the actual orbit which it was supposed to reach, which was around 550 kilometers circular, it did not reach that. It might be like 550 kilometer by 160 kilometer, 150 kilometer, or something like that. So basically what has happened, if I can tell you that, from whatever information I have been given from the live feed, that the second stage did not, maybe the second stage had some problems lighting up, because it was supposed to light up way before, means at that point of time when they said there was some issue, and the cosmic girl has landed safely, guys. You can finally see that. So there you go. At least humans are
as
good.
We see Cosmic Girl touching down back to UK Spaceport Cornwall. She did a magnificent job today and was fully successful in her portion of the mission. As I had said earlier, Virgin Orbit's #1 priority is the safety of our flight crew and the folks on the ground as well. So we can see that she has come home safely.
Is like they also don't know what is happening, and confusion everywhere. Confusion is and confusion and confusion. no matter, the space is hard, and it is always kind of difficult to master it in very less flights. So I always say that around, let's say, 10 to 15 flights, anything can happen. After 10 to 15 flights, you get to have the confidence in your technology, and then if anything else happens, then it is kind of a new thing for you. But in 10 to 15 flights, you get to learn and test out all the scenarios which could happen. So yeah. But yes, Louis Smith, don't worry about it. The liftoff part from the UK, the takeoff part from the UK went very well, and the Cosmic Girl did her job. But yes, again, the space is hard, and it might not have reached the orbit today. But see, again, we don't know. We don't know. The problem is this only. There is so much confusion because nobody knows what is happening. We have not gotten any telemetry, and whatever telemetry we got was bonkers. So yeah, this is the first stream where a failure has happened and I can't do failure analysis. This is the first stream of mine because this is what it is. I just can't do anything. I don't have the enough information on what to analyze. I just can't. So yeah, we'll have to wait and see and wait and hear from the Virgin Orbit itself actually, yeah, what actually happened there. Thanks, Louis Smith, and thank you all for joining in. Also, mods, you did an amazing job today. I am thankful for all of you. Thankful to all of you that you made sure that that the chat is as civil as possible. So thank you so much for that. Really appreciate it. But yes, this has happened now. Yes, the rocket has failed. The rocket has failed, Graham. The space is hard. Can't blame them. Space is hard, like literally very hard, very hard. There is a, why is there a pattern that whenever a company comes into space, they need to face failures and all those things? Because like literally even the veterans company, the badass company, NASA's and all those, SpaceX, can't say about SpaceX though, but still, all those companies do suffer some from these anomalies and these failures time to time, because space is so freaking hard. Otherwise, after we have gone to space so many times, but we still again and again get to face some sort of failure, some sort of anomalies, or some sort of something like that. And there is a reason, because it is literally very hard. You are controlled. Rocket is nothing but a controlled explosion, and explosion is always an explosion. So no matter how much you control it, it can go out of control. So that is a thing. Wallops will launch, yes, Storm Chaser. I know the Rocket Lab was supposed to launch their rocket from the Wallops, but it got cancelled. And then it was actually, it is supposed to launch. Let me just tell you when. Okay. So this happened. So now the Starlink. Oh, okay. So this is interesting. So in just 20 and 15, 35 minutes gap, two launches will happen: SpaceX Starlink launch and then OneWeb 16 launch, which is kind of interesting. So two launches in just 35 minutes gap. Wow. One launch from Vandenberg, one from Cape Canaveral. Cool. Other than that, we have the next launch. So Falcon Heavy launch is coming up, guys, on 14th of Jan, which is interesting. And okay, so the Virginia is for launch lovers. The Electron launch is still on the cards, but we don't know when it will be launched. So we don't have this stream. It's 5. Shukrayan might be delayed to 2031. No, Dev Pratim, this is not a good news to sleep. Wow. Okay, no worries. What can we do? But yeah, so it's 5:30 a.m. here, guys, and I guess it's time for me to go and sleep. Can't continue this stream anymore, and obviously we'll post the updates, whatever we will get on my Twitter. So do follow me on Twitter. Right now the latest update is that the Virgin Orbit has declared a failure, and other than that we haven't. Okay.
Welcome back, and thanks for sticking with us for this long, everyone. We have experienced an anomaly, and we are gathering more information. I did want to take this opportunity to thank our customers, our Virgin Orbit team, VONS, UK Spaceport Cornwall, of course, and our BSL interpreters over in the UK. We're going to be ending our live stream at this point, but please be sure to check out our other channels, our social media channels, for more information as soon as it's available.
I'm totally confused about what has happened, but we'll get to know when things will come into existence. So, but yes, that was it. That was the latest update. That Cosmic Girl has returned to the safely returned back to the flight airport. Okay, so this is the latest tweet from them. But yeah, the mission was not a successful one, but no worries, the space is hard and these kind of things happen. But UK will soon experience the first successful launch, because this has not happened, so this is supposed to happen again also. So let's hope we'll get to see something very soon. So thank you so much for tuning in, guys. Really appreciate it. And if you haven't subscribed already, do subscribe to my channel. It would really mean a lot, and I'm sure you won't regret it. Thank you so much for tuning in. And until then, this is Piyan Shirola. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.